Hi everyone, I am Milan, and in today's video I will show you how to create beautiful raster maps using the European Commission's Global Human Settlement Layer, which is a global population density map data. So let's get to it. After minimizing myself and putting myself right up here, let me just first hide all the ugly things by just importing warnings and ignoring warnings, and then parsing the first library that we are going to use to read the data. It is going to be rioxarray, so import rioxarray, and just to make sure we are on the same page, I just check the version I'm using here. And after that, I will cheat a little and copy paste the folder where I store the data file, because this location is not really one that I would like to read out loud or type here on video. So I just do it like this and use the rioxarrays parsing module to read this file using the file path and setting a few parameters and calling it a data array. So it's done, so we just parsed the data array, and let me see how it looks like. So the uncompressed underlying data consists of about 4,000 chunks and measures almost half a TB, so that's a gigantic piece of data. So the first thing I'm going to do is to filter it down to have a smaller geography, for example Europe, not the whole world, so I will get something that's probably manageable on my laptop. So let's start to prepare the data. For that I will need another package to manipulate the raster file. It's going to be xarray as xr, and I will also use numpy as np, so let's just have it here as well. So I will call data array C the cropped version, which is going to be the clipped version that's clipped to a bounding box, and here I'm cheating again because I have already tested a nice bounding box, so I just copy it here from the other screen. Just a sec, it's almost there. But here feel free to change this bounding box to any other bounding box that you are interested in, and let me know how those maps look like. So here we have one bounding box, and let's see how the data looks like after clipping it. Okay, almost there. Something is off. What's the issue here? Yeah, so there we are. So we have a clip version which is only 10 gigabytes and 90 chunks, so that's actually something much more reasonable. So keep moving on and do a few more pre-processing and transformation steps. First, just do some typecasting and have an array, a data array from the XR package. Then doing some reshaping. After that, I will get rid of all the zero elements and just evaluating this comment here. And finally, we also need to flip this image using numpy, because for some reason their default coordinate system would result in an upside down map, so I will just do that as well. And while the processing steps are still running, I will start importing the visualization part. So importing datashader as ds first, and then from datashader I will import the transfer functions as tf, and from the colorcet library I will import the plat. There is something wrong with the kernel, so let me just restart it right away. Plat. Sometimes this happens, especially if we are working with large files, so there is some memory overload issue. Probably some of my other programs are running in the background, which overloaded my poor old laptop. So let's hope that this time it will go through. And while it does, I keep typing, so we will also need to set the size of the final image that we are plotting. And for that we will also need the aspect ratio of the final plot, which is quite easy to get from the data array's shape. And this will be like get the image size part. Then we create the canvas for plotting, CVS, and that's going to come from the data shader. It will need a plot width and the plot height parameter, which we can compute from the size and the aspect ratio. And we can use this to create the final raster that we will show. Okay, there is an issue here. It's division. Okay, almost there. And finally, just draw the image. For that, we will need a color map from the palette. I'm going to use the BMW, but you will find a bunch of other nice palettes from the on the HoloViz website here. So let's get to the image. Using the data shader, we will add the raster that we prepared. We will use histogram, equalisation, and the color map we just created here. I will also set the background to be black. And finally, this is where the magic happens. There we are. Okay, perfect. So here we are. Here we have this beautiful map of Europe. You can see that the population densities are drawing up pretty nicely. We can see the central areas around big cities like Madrid, Barcelona, Rome. Maybe even here, yes, in Budapest, that's where I'm right now. So this is how we create this beautiful map. And this was actually the topic for today, so thank you very much for following me through this, and let me know how your maps look like. Bye.